Hello, today we're going to take a look at multi-threading in Rust. So I'm going to look at how to start threads and also how to pass messages between threads. I wouldn't say I completely have this memorized yet, so I'm probably going to be referring to this draft of my blog post on blog.caveofprogramming.com, which I'm going to add this video to when I've finished it. So let's start by creating a thread, and I won't go into stuff about what a thread actually is too much. I'll assume that you actually know that. But it's basically a separate process that runs in your program so you can run multiple processes concurrently. So we need to include standard, I think it's thread, maybe. Let's try that anyway. See how much I can remember here. And then to actually start a thread, we need thread spawn, and we pass a closure to that. So kind of like a lambda expression type of thing in other languages. So we've got these two vertical bars and then the brackets where the code actually goes. And let's put a loop in there. So for I in 0.5, maybe, put some brackets in there and we'll have print line, and in there I'm going to have, what should I write? Let's just put thread, and I'll put I in there. I think put it here, don't I? So that might work. I'm not sure. Let's try it out. So we'll do cargo format, and I'll do cargo run. Yeah, I've not got the import right. I'm going to have to check what it is because I just don't remember. What is it? Oh, it's just standard thread. It's simpler than I imagined. So I just got to get rid of that, and now it might run. Let's try that. Yeah, it runs, and you notice there's no output from it, which I kind of expected. The reason for that is that as soon as this main thread terminates, because there's always one thread in your program, the main thread, and as soon as that terminates, it's going to terminate any threads that we've spawned. So this doesn't even have time to do anything. And what we need to do is wait for it somehow. So one kind of low-tech way that we could wait for it is just to put a delay in the main thread. Let's use standard, I'm never going to remember this, am I? What is it? Standard something with duration, maybe duration. That can't possibly be right, can it? Let's try it. Duration, sleep, pretty sure it's sleep. And now we specify a duration using duration. Yeah, but that would have to be capital D if that's true. I can try that. That's not going to be duration sleep. That's got to be thread sleep. And duration from milliseconds to get a delay in milliseconds to specify that. And let's make it sleep for a second. Now, if that code compiles, we should see output. Okay, that's not right. What did I do wrong? Check my notes. It's standard time duration. I should have guessed that. All right, so try again. Yeah, and now it works. So the thing about this is that's executing concurrently with the main thread. So let's try to prove that. I'm going to copy that and paste this maybe in here. I'll just save it and I'll do a cargo format. Cargo format. Save me having to indent it manually. And then let's try putting a sort of sleep within these loops. So I'll have one there. Let's maybe just cut it down to something small, like even a millisecond would probably do. I'll put 10 milliseconds in there, and we'll have the same thing down here. Make this a bit smaller maybe, if I can remember my shortcut that I set up, and I can't. Wow, I totally can't remember the shortcut I set. Let's do Command-Shift-P and editor decrease font size. So the increase one I've set to Shift. No, what's that? That's Option Shift dot. The decrease must be Option Shift comma, because I remember I chose those two keys. It doesn't do anything when I press it though. Nothing happens. All right, editor. All right, decrease editor font size. Yeah, there you go. What am I doing wrong? Oh, it's Control Shift comma. Okay, sorry about that. I would cut that out, but I sort of think like if you're struggling a bit with Visual Studio Code as I do from time to time, maybe it's useful, so I'll leave it in. All right, so now the idea is that this is going to get spawned. It's immediately going to start running, and this is not going to wait for all that stuff to finish because it's in its own thread. So these two threads, the main thread and this thread, are going to execute concurrently. That's the idea. Make that a bit smaller. All right, so let's try this. So I go to the console. That's really small now. What's happened? Let's go to View Appearance, Reset Zoom. It's really that small. I'm going to try to increase this. Yeah, okay, I've got a shortcut there as well. All right, so cargo run, and there you can see output, and it is interleaved. So can make that a bit clearer, I think, if I put maybe A there and B there, and if we try those. So you can see A and B are interleaving. The reason that I need this sleep here is if I don't do that, it's entirely possible that one of the threads is just going to finish before the other even has a chance to get started. And it would probably be this thread here. So if I comment those out like this, and then I run it again, yeah, we've got, so B is coming out, that's the main thread, 0, 1, 2, 3, 4. And A, in this case, has just got started, and then it's been cut off. And sometimes you don't see any output at all. The computer where I developed this initially is much faster than this incredibly old iMac that I'm recording this video on. And on that one, I only see the output from B. And the reason is that, so this is kind of starting to get spawned, and then this whole thing just runs before this even has a chance to get going. However, there is a smarter way to wait for a thread to finish, and that's to use join. So this actually, spawn has a return value. Let's say I'll call it handle equal that stuff. And this is basically taken from the Rust documentation. I'm not really inventing anything original here. And then at the end, let's wait for this thread to finish. So I can say handle.join. Join is it always strikes me as a very unintuitive name for what we're doing here, but it's the same in many languages. Join is just waiting for a thread to finish. And I guess the idea is you're sort of joining the thread somehow, but I've never really understood how, to be honest. It seems a bit unintuitive, but anyway, handle.join. In fact, at the minimum, I think that's all we need to do, but this will probably give us some kind of unused variable warning, maybe. Let's try it. Yeah, so it works, but we see we're ignoring the value that join returns. And what we get out of this is we get both threads have executed. They're not interleaved because one thread managed to finish before the other even started. To get rid of that warning about the ignored return value, because it does return a result, so I can do .unwrap, and that will just panic if the thread can't be spawned, I suppose. So otherwise it will unwrap the value, which we could get here, but we're not going to use it anyway. So let's try that, and you can see that that's fine. And if we put back in these sleeps now, then we will ensure that the threads do interleave. So there we go. Now we've got the kind of output getting mixed up. In this case, with relatively big delays, like 10 milliseconds in the scheme of things with a computer is, a long time in a way. You are, I would think, always going to see totally interleaved output. The only way that we could get a bunch of these coming out from one thread without the other outputting stuff would be if one of the threads took more than 10 milliseconds to start up, which is not likely to happen. We could also spawn two threads, which maybe would be a slightly more intuitive arrangement. Let's call this H1, that's the handle for the first thread, and just copy this and duplicate it, and I will get rid of that, and we'll call this B. And at the end, we can wait for both threads to finish, so H1 and H2, and this is going to be H2. I'll do cargo format, and then I think, so what we've got now is two threads that are both outputting text with a delay. So if I try to run it, now we get, again, interleaved output like this. Now at this point, the documentation goes into something which is not strictly a thread thing, but more of a closure thing, but it is extremely relevant to what we're doing, so we better have a look at it. Suppose we have a value here, let's say let v equal 7, and then we try to use that within the threads. So I could say, for example, println, and here, a couple of speech marks, brackets, and V. That doesn't work. Let's try it. So if you take the time to read the error message, basically what it's telling you is that this isn't going to work because V might outlive the thread. I'm just trying to think, is this a thread thing or is it a closure thing? I think it's just a closure thing. So, for example, you could do here v.drop, and so that will get executed. The thread will start running in the background. If you've got multiple CPUs, it may use one of those. You probably do have multiple CPUs. If you start up more threads than you've got CPUs, it's going to do this kind of micro slicing thing where different threads get different tiny fractions of time interleaved on the CPU. So it will look like you've got real multi-threading going on. But whatever actually happens, this is going to start running and this is going to get dropped. And that's meanwhile still going to be running. So that wouldn't be valid anymore. And for that reason, you're not allowed to do this kind of thing. You can't just reference local variables directly. One thing you can do though is just put a move there, and then we're not allowed to do this, because what that does is it means that all the local variables that you use in here are actually moved into this enclosure apparently, and that would mean that this is no longer valid by the time we get down here. So that won't compile either, but it will if we get rid of this v drop now. So let's get rid of that, and then we can see that we're outputting 7 in that thread there. Let's get rid of that for the moment. We are going to make use of it though, so I'll get rid of this and this. Let's just maybe put it back like this just for a moment. Alright, so if you've done any multi-threading, you know that there are issues around multiple different threads accessing data. So this isn't actually possible in Rust. So this is an example of how Rust kind of protects you. Let's say we have an integer there, which I'll just call it value. And suppose we try to increment it from here and here. Well, in Rust, we wouldn't be able to even do that because we would have to have a move there, so the value would get moved and then it's not available for use here. Once it's moved, that thread or the code here has ownership of it, meaning you can't use it down here. Other languages would let you do that. So they would let you modify value from here and also from here. And suppose, for example, these two threads were doing something as simple as just incrementing that value. If you're an experienced programmer, you'll probably know where I'm going with this. What happens is the two threads end up overwriting each other's efforts. And you think, well, if all I'm doing is incrementing it, surely that shouldn't be a problem. But if you look how incrementing a value compiles to binary code, if you look at the assembly language version of it, for example, you see that even incrementing an integer is not an atomic operation. The value actually gets moved to a register in the CPU, it gets incremented there, and then it gets moved back again or something like that. So it's a multi-step operation, and you can imagine that if this thread were to move this value to some register, and this thread did the same thing, and this one increments it, and then that one increments its copied value, and then they store it back where it was originally, what you end up with is the value is not incremented twice, but only once. So you wouldn't typically expect to see that happening every time the value is incremented. Sometimes it would work, other times it wouldn't. But in Rust, unlike in, for example, C, C++, Java, we can't even do that. So we need alternatives. And one alternative that we're going to just look at here, or start looking at, is we can pass messages between threads. So what we're talking about here is inter-thread communication, really. And having multiple threads modify the same variable would be an example of threads communicating. But unfortunately, that just doesn't work in, well, not really in any language that I've tried anyway. But we can communicate between threads using a message system. So what we need up here is use standard sync and what is it? MPSC, I think. This stands for multiple producer, single consumer. So the idea is if you use this, you can have multiple threads producing values, and and sending them into a channel, a kind of data channel. And you can have a single consumer that then reads the data from that channel. So we'll take a look at an example of that. Maybe I'll copy this file to something else so that it's going to be available in the GitHub repository. If you check out blog.caverprogramming.com, I'll link it there. Let's copy main.rs to threads.rs because I don't need this stuff now, so I'm going to get rid of at least that. So the first thing that we need to do is create this kind of message channel that we will use for communication. So I'm going to say let, and we have a tuple here, and this is, not sure about the order, but let's try this, TX and RX, which apparently are common names for the transmitter and receiver. So the idea is that the transmitter sends data, or we send data to it, or we send data down a kind of channel using this, and we receive that data using this. I'm going to set that equal to MPSC : channel. Now we want to send some data down this channel. So let's maybe have a loop or something. So for I in 0.3, that should be enough to demonstrate the idea. And then we can do tx.send and send that value, which I guess is going to get moved into the kind of send function here. And that has a return value, which we will ignore, but to avoid any kind of messages, we'll do unwrap, so we don't get the ignored return value message. And then if something goes wrong with this, like for example, if the thread that was going to receive from this was no longer running, then in that case, this would just cause a panic, I should think. I believe so anyway. So we're sending data down this channel that we've created, and in this thread, we can receive it. Let's just change that to H1. And if I send multiple values, actually maybe it's better if I first demonstrate it without this loop. Let's just have a send, and I'll just send a single value down to start with. And then in here, in this thread, let's maybe comment out the sleep, and I'm going to do let v equal tx, no, we want to use the receiver, rx dot, so receive, that's rec v, that's just short for receive, and we can unwrap the value from that, so we'll just panic if we don't get it. I think that's right. So let's try now. Actually, we need to get rid of this whole loop really. So put that there, get rid of this. Let's just get rid of this. I can retype it if necessary. And actually, I've changed my mind. Let's get rid of that. Try to create code that's a little bit clean here. All right, how are we doing? I think that's just about it. I'll do cargo format. So cargo FMT. All right, so we create the transmitter and receiver channel. We use the transmitter to send data from some thread. And then from some other thread, we use the recv or receive method to get the values that are sent into that channel. And then we should be able to print them right here. Let's write thread here. And I'll wait for this thread to finish. So let's try this. So cargo run. Yeah, I did something bad here. I've got to get this. I want to print this out, not I, which is gone now. All right. Oh yeah. So now I have a problem which confused me at first, but if you go up to the top, maybe it's less confusing, or maybe not really. Yeah, it's saying that the receiver cannot be shared between threads safely. What we actually have to do here is put a move in. So we're actually moving this into this thread here. And since I'm not using that, I'm going to comment it out. Let's try again. Yeah, and now you can see that we've successfully received and printed a value. And we can send multiple values quite easily here. So if I say for I in 0.5 or whatever, and then I put some curly brackets in here. So we could probably just have multiple calls to receive. Haven't actually tried that. Maybe I should try it. Let's just duplicate this. I'm curious what happens. And now if I run that code, yeah, what happened there? Yeah, I sent 7, but I meant to send I. Okay, that's a better test of it. Let's try this, see if it gets 1 and 2. Yeah, so we've got 0 and 1, that's correct. That's what we're actually sending. But you can also just use the receiver as an iterator. So instead of doing this, instead of using the receive method, I can do for I or whatever, maybe call it V, in Rx. I put some brackets in here and then move this up here. Let's get rid of that. I think that looks good. So we send a load of values using the transmitter, and then we just loop over the receiver, and that should give us the values one by one, I think. So if I try it, yeah, we got 0, 1, 2, 3, and 4. And just to prove that this is actually a multiple producer, single consumer, we can have multiple producers. So this is our producer. But for example, we could do this in a bunch of threads. Let's call this receiver, and let's wait for the receiver to finish. And then I'll have a producer, maybe a couple of them. So if I just make a copy of that, call this producer 1, and then I want to say for I in whatever, I'm going to send that stuff down the channel. Now the question is, okay, so that's going to move any local variables used within this block. That's going to move them so that the ownership is then taken by this code here, meaning we can't then use tx again, which is what I want to do. What I want to do is like this. So we have a second producer, and we use that to send data down the channel as well, maybe even different data, like for I in 10.5. Can I go backwards? Not actually sure. You can certainly try it. But that's not going to be valid once it's been moved into there. And that problem is easily solved. Let's call this tx1, and we'll say here, let tx2 equal tx1.clone. It's as simple as that. And then here I can use tx2 to send data down the channel. And then our receiver is going to then receive all of that data. I'm not sure about this loop syntax though. I've forgotten how you do a reverse loop in Rust. That hasn't actually finished. So a question here that I have is, do I need to wait for the producers? Maybe. For sure it's not going to do any harm. So let's put in here, let's duplicate that a couple of times, and we'll have producer1 and producer2 dot join. So we're waiting for all the threads to finish now. All right, so let's just kill this with Control C and run. Yeah, that backwards loop, my attempt at a backwards loop, just didn't work. Let's go to Copilot and ask it, how do I write a reverse loop in Rust? This is great, by the way. You don't have to log in even, and it answers your questions. Answers them better than I could in most cases. Not in every case, but in most cases. So we want, that's not a oh yeah, we need the dot reverse thing, right? So if I go to here, I'd forgotten about that, to be honest. So if I put 5.10, and I need to put that in round brackets because we need to call a method on it, which is reverse. Let's try that. Wow, what's happened? Something's gone really wrong. Just zoom out. Okay. All right. Yeah, so I think that looks good. All right, so let's clear the screen. I'll do a cargo format and cargo run. And there we go. So we've got 0, 9, 1, 2, 3, 4, 5. No, there's no 5. 8, 7, 6, 5. So all the numbers are there, and they're all kind of interleaved in a slightly random order. And in fact, you can't rely on the code in different threads executing in any particular sequence. They're just going to do what they do as fast as each thread can manage it. So it's going to be a little bit random. If you wanted precise synchronization, you have to have some kind of further synchronization technique. But most often with multi-threading, people say best thing to do is write your code in such a way that you don't rely on threads doing anything in any particular sequence. Each thread should just do its own thing without having to worry about other threads too much. But what we could do here, which is interesting, is I could say, what is it? Thread sleep, I think it was. And here we have duration from milliseconds from millis, and let's make this 500 maybe. And I'll do the same here as well. So the two producers are now producing values, sending them down the channel, but with a bit of a pause. It takes a bit of time for the stuff to get sent down the channel. And there's no pause in the receiver. That's just going to read values as fast as it can and print them out. Let's try that, see what happens. So when I run this, I get an error because I've forgotten something. What have I forgotten? I've forgotten that I got rid of this. So use standard time duration. Okay, try that again. So if I run this, you can see that the values are being produced, and as soon as they are produced, the consumer consumes them and it's printing them out. And then finally, when all the values have been consumed, even the receiver or consumer thread will actually quit. So this returns and the program can actually end. Okay, so that's it for this video. That's a couple of pages in the Rust documentation. For me, this wasn't too difficult. The basic thing of creating threads is practically the same in every language, really. It's just, of course, we have to do it in a Rust kind of way here because it's Rust. This business about sending messages down a data channel, I think is really intuitive. Not sure if I've really come across that in exactly this form before, but the producer-consumer pattern I certainly know. I've implemented that in lots of other languages. And, in another language you might do this by having shared data. Like in Java, maybe you could use an array blocking queue or something thread safe that you can write values to and read values from. But Rust isn't going to let us do that, so we have to use something else instead. Okay, so I'll take a look at what's next in the documentation and we'll cover that next time. I do know a little bit further ahead because I started working on it by mistake, overlooking this section. There's stuff about async and wait, so we're going to get onto that in the fullness of time, but there's probably a couple more pages in this particular section of the docs that we need to cover first. Do take a look at blog.caveofprogramming.com. It's totally free and you can subscribe for free as well. Actually, I say it's totally free. If you subscribe and you pay me a minimal amount, like $5 a month or something, I think it is, you also get access to my Mastering C course. So do consider that, and until next time, happy coding.